Okay, so this is on how to do notes on a trend line. So notes for a trend line is basically a line, or sometimes we can call it the best fit. You can sometimes call that the best fit line. Um, and that's it's gonna basically follow the pattern. So you're gonna go through and that's gonna follow the pattern of the data. And the data meaning the points. So if you look down here at this example, you've got all these little points down here and you're going to follow that particular pattern. And it's got about half the amount of points above and half the amount of points below. So you're gonna split about. It's not going to be perfect. It's just going to be a good little estimate. So now when you go through, and we're going to make this big so you can see, now what happens is given the graph at the left, you're going to find that best fit line. So when we go through and do this, you're going to think about this, and I'm going to make that really big so we can see. And when you go through and you're looking at all of those particular points, and you have to find that fit line. And so you think about it has to follow the pattern. So our slope will probably be positive because all of those little points, as x increases, my y value is also going to increase. So what I like to use in order to do this is just a little piece of spaghetti because it's a nice little idea. And it's got to follow the trend. So if I just kind of look at this, that's not following the trend. But it does split my points in half. However, it is not following the trend. So then I go this way, and I got about half the points. It's still not following the trend. And the other common mistake that students do is they'll just make it, oh yeah, I'm going to go from there to there. I'm going to go from 0 to there. But if you notice, you still have all of these little points. You got more points above than below. And all I did was go like from here. So I'm going to make my points so we can actually see them. I'm just going to make them a little darker. I'm just going to color them a different color so we can actually see. All right, so those are like your lovely little points so we can see. So if I look, and if I went from 0 and I went to there, you can see automatically that you're going to have more points above. So it's not always going to be perfect at 0. So there's definitely more points above your line. There's only like 1 point below. So that's not a good line. So in order to find your line, one of those things that I like to do is I kind of use my spaghetti because that really is a good idea and I can kind of look and I can see. And yeah, there's some 1, 2, so above there's about 1, 2, 3, there's a few dots above that. So that's pretty good line. So what I like to do is I like to take my little spaghetti and then I just like to use my spaghetti as my guide. And then and you notice when I move it, it's easy to move if I just push it with a pin. So if I use that to make a line, it's going to move and kind of mess me up. So I just make little dots. And then there's another dot. And it looks, I said, that's about right there. So now what happens is I've made 2 little dots. Now you go through and with your straight edge that won't move when you trace, it's a nice little idea. And now you've made your line of best fit. You've made your line of best fit, your trend line, and that's a pretty good system. So now you find 2 points along your line. It doesn't matter if it's one of your original points or not. It does not need to be around one of your original points. The thing that makes your life easier is if I look at that point right there. So if I look, this is at 3. My x value is at 3, and then my y value is something. So I know x is 3, and then I'm going to figure out what this y-square is. So 1, 2, 3, 4, 5. So to go from 0 to 100, it's got to count by something. So what I did is I just went 100 divided by 5. 1, 2, 3, 4, 5. That's how I got my 5. So 100 divided by 5 is 20. So let's check it. 20, 40, 60, 80, 100. So each one of these is 20. So there's 100, 120, 140. So my answer is 140 there. That's point 1. So then I have another point along my line. So if I look at my other point along my line, just any point along that green line, and I try to find, this one is pretty good. So that one is going to be, so I go down, and this looks to be about 9.9. And then I go over here, and we're still counting by. So I went down. So it looks to be about 9. And then I go 200, 220, 240, 250, or 260, 280. So 280. And again, you are drawing a line of best fit. Your line will definitely be different or will be close to, but it could be a little different than mine. It's not going to be the same thing because the whole thing is that their lines can be totally different. So the next thing is we need to find the slope. So remember your slope formula, y2 minus y1 over x2 minus x1. So my y values are my second ones, and remember y is always to the sky, so 280 minus 140. And then my x values, and we start with the second point, so 9 minus 3. And you're going to use your Desmos friend to find that equation. So 280, I'm not doing this by myself, minus 140, and so obviously I like to use my calculator, and all I did was 280 minus 140 to kind of get this. 280 minus 140 gives me 140. And then I go 9 minus 3, I can do that in my head. And then what happens? I like to go through and I like to put them in 140. I like to put them in decimal notation. So 140 divided by 6 gives me 23.33. Okay, notice that when you go through and do this, these are not going to be absolutely perfect. When you go through, you're not going to, and you could have something. So I would assume that Penny's little savings account situation is she is gaining money about $20 to $30 a month. So your neighbor, if you were going to do this, or you have a friend that you want to call, you say, hey, what did you get for a slope? Okay, so you would assume that your slope would probably be about 20 to 30. That's a logical slope. All right, the thing that we don't like the most, what is used all the time, is the real life context or the real life meaning of slope. So that real life meaning of slope, so we're looking at Penny's bank account. So we look at the title of our graph, which is Penny's bank account. We're looking what X represents, so that's your months. And then this one is your balance. So how much money does Penny have in her account? And so we have that our slope, so we just figured out that the slope is equal to 23.33. Okay? And so basically that means that this is your money per month, every month. So every 1 month. So every time she, on average, so the real life meaning would be on average, her balance increases so her balance is going to increase by $23.33 each month. That's the real life context. So that is that real life context of that. And now we're going to go through and we're going to write in point slope form. And again, you just had a quiz on this and writing in point slope form. So y minus y1 is equal to m, and then x minus x1. And remember, we just found m. We just found that slope. So this would be 23.33. 23.33. And it doesn't matter. So remember, when you're writing in point slope form, it doesn't matter if you use your first point or if you use your second point. So you can have your equation would be y and x. So this would be for point 1. So if you have this for point 1 and you're going to plug in 3 and 140, remember the 140 goes with y. So the opposite of positive 140 would be minus 140. Okay, and then you have your slope, which is 23.33, $23.33. And then your x value of your first point is 3, and then opposite of positive 3 is minus 3. So that's point 1. You can write that. Or if you liked point 2 better because it seemed nicer to you, then you can use point 2. I don't care. You're going to get the same answer if you're going to use point 1 or point 2. So this was going to be y. And then you had your slope. That's not going to change. 23.33. That's not changing. That's your slope. It's next to x because they're in a relationship together. And now your second point is your y value is 280. So the opposite of 280 is minus 280. And then the opposite of 9 is minus 9. And so what happens is you're going to go through, and now that's writing point slope form. And you can use your Desmos, desmos.com, and you can check to see, hey, does that go through those points? Did I do my point slope form correctly? Did it go through these 2 points, 3, 140 and 9, 280? Did it go through there? And if it did, then you're golden and you did this correct. So the next part, convert to point slope form. So I'm just going to use my first point because it's less stuff and I don't have to multiply in such big numbers because I'm kind of lazy. So y minus 140 is equal to 23.33 x minus 3. That's step 1. Step 2, we got to go through and we have to distribute our slope. So we're going to go through and we're going to multiply by our slope. So y minus 140, that stays there and waits its turn because we're not doing anything with that. And then I'm going to go 23.33. So 23.33 times x. So that's 23.33x. And 23.33 times negative 3. Use your friend. So use your friend. And you're going to go 23.33 times negative 3. And so you get negative 69.99. So negative 69.99, which is about 70. So I ran out of room, so I'm going to rewrite this, and I'm going to move this over to over here. So now we have y minus 140 is equal to 23.33x. And then I'm going to round this, and then that's minus 69.99. So now we have to go through and we're going to solve for y. So the opposite of subtracting 140 is going to add 140, 140, and then you get y equals, and you have 23.33x and negative 69.99 plus 140. So I've got my negative 69.99. And now I'm going to add 140 to that. And I get 70.01. Now all I'm doing, and that's fine that you're using the calculator. This will make it so we don't mess up. We've already got some difficult stuff going on in our lives already. And it's a little bit easier. You can look at that, and if your point slope form and this pretty much go on top of each other, then you know that that is correct. So you're going to test that into Desmos. Okay, so the y-intercept. The y-intercept in this case, first of all, we got to figure out which one of these numbers, 23.33 or 70.01, is your y-intercept. So this case, the y-intercept is going to be 70.01. And so this means that Penny, because we're talking about Penny's savings account, so Penny, when she started her savings account, that number on the y-axis means that she started her savings account at $70.01. So Penny started, or you can put opened her account with $70.01. That's that real life context of y-intercept. Penny opened her account, or she started it. So at month 0, she walked in and she had $70, and she probably found a penny on the floor and said, "Hey, can I just put that in too?" And then, of course, they said, "Oh yeah, sure, we'll deposit it." So the next thing, assuming Penny will continue with this trend. So this trend, remember, is that every month she's going to put in about $23.33 every month. How much money is she going to have after 18 months? So we have our calculator, and solve algebraically means you're not going to look at a table, you're not going to look at a graph, you're going to actually solve algebraically. So you're going to use your equation. So your equation is y is equal to $23.33. And this thing, x, is 18. So x is equal to 18. We need to figure out what y is. That's basically what that question is. So 23.33 times 18 plus that $70.01. So we're going to use our friend. You're going to use your little friend, and you're probably going to use your Desmos friend. So this is 23.33 times 18. So 23.33 times 18. So just like I did, 23.33 times 18, and that equals $419.94. So basically, Penny just put $419.94 in, plus her original amount of $7 and a penny, or $70 and a penny. So we add that together. So now we go plus 70.01. And now she's at $489.95. So this is a rough estimate of what Penny would have in her account. So basically, the cool thing about putting money into a bank and putting money in a savings account is she's gonna actually have more money than that, because you have to invest it. And then that will come in chapter 6 when we do exponents. And so we'll talk about that piece. But this is just how much money that she has put into her account after 18 months. So now, this is the tough question. This is that real life tough question. Penny would like to follow this trend, and she wants to know how many months will it take her to get $1,000. How many months? So approximately how many months is that going to take her to get that $1,000? Again, we have to solve algebraically. So we have to use our equation. Y is equal to 23.33x plus 70.01. That's our equation. So this $1,000 here, that's going to be y. Y is equal to 1,000, and we're going to find x. That's our months. So that's going to be your months. How much money? So we're going to substitute 1,000 in, and then we have 23.33x plus 70.01. Now here is where that was really important, and why I did the dirt table and why I gave you such difficult problems. Because you have to do the undo. So I'm going to cover up 1,000. What am I doing to x? So I pick x. So when we went back at the beginning of the year, you had the dir. And you have x. And then we're going to multiply by 23.33, and you add 70.01. Okay? And then my answer was 1,000. So what happens is, now in order to undo all this, you got to work from the bottom up. So the opposite of adding 7001 is to subtract 7001. So I'm going to subtract 7001. So 1,000 minus 7001 gives me $929.99. So the next particular thing, the opposite of multiply, is divide, 23.33. So we're going to go through and we're going to divide by 23.33. And I'm going to take my number. And this time you get your answer to be 39.86. Okay, so that's using the DIR table to solve this. I can make that bigger for you, sorry. That's going to use the DIR table to solve this equation. However, you don't have to use the DIR because that was just getting you to remember to work backwards and opposite and to undo things correctly. We're still going to undo this equation. I'm going to move this over. We're still going to undo that equation. And if I've got this describe process, which is PEMDAS, I still have to undo. I'm still picking x. I'm multiplying by 23.33. And I'm adding 70.01. So in order to undo that, I'm going to go through and I'm going to subtract 70.01. Subtract 70.01. And when you go through, that cancels out. And now what happens, this is 23.33x equals 1,000 minus 70.01 gives me that $929.99. And then that opposite of multiplying, because a number and a letter stuck together, they're multiplying because they're stuck together. That's that operation in between is multiplication. That's multiplying. So you're multiplying. The opposite of multiplying means that I'm going to divide. So the fraction bar means divide. And you're going to divide this apart. And you're going to divide this apart. So then x, because 23.33 divided by 23.33 cancels out. That's just one x. And then 929.99 divided by 23, this ends up being about 39.86 is x. So this would be about, the answer to this would be about 40 months. The answer to that question is about, oops, sorry, I meant to make it smaller. Is about 40 months. That's the answer to that question. So this will take you about 40 months. Now remember, this is the trend line that I drew. Your line can be totally different than somebody else next to you. Your answers should be approximately the same. They are not going to be 100% the same, because a trend line is an approximate line of best fit. It's not the perfect line of best fit. It's just approximate line of best fit. So that's how I go through and I find the trend line, and then you write the equation y equals mx plus b. Then you go through and you do that real life context of finding things and using algebra. Using your algebra to check to see if it works. And you're not going to get a perfect answer, but see all this work. And this is where you get to pick. If you love doing the DIR table and that totally made sense to you, you do the DIR table. If you don't like doing the DIR table and you want to solve traditionally, like Mr. Churchill or Mrs. Abarno taught you last year, then use the standard process. The only reason why I taught you the DIR table is because some people need this little step-by-step process, and it is to look and to make sure that you are going to subtract or add, because a lot of my students, I found before I started teaching the DIR, is that they would divide first and then they would subtract 70.01. So that is why I teach the DIR. So again, this is real life context of trend line and why you would actually use it. So you do have a homework assignment about trend line, and